At 8:30 in the morning, the sky above central Guatemala started to change color. Within hours, a column of ash and gas had punched nearly 6 kilometers straight up into the atmosphere, and by nightfall that column had spread so far and so wide that it was drifting more than 80 miles from the volcano that produced it, turning daylight hazy and the night sky an unnatural glowing red. This is Volcán de Fuego, the volcano fire, one of the most dangerous and most active volcanoes anywhere in the Western Hemisphere, and it just erupted in one of its most violent episodes in years, close enough to Guatemala's capital city that residents there could watch it happen from their own rooftops. Today we are breaking down exactly what happened, hour by hour, why this particular volcano carries a darker history than almost any other in Central America, and why the response happening on the ground right now is being shaped directly by a tragedy from just 8 years ago that this country has never fully recovered from. No exaggeration, just the actual timeline, the actual science, and the actual stakes for the people living in its shadow. If you have ever witnessed a volcanic eruption, tell me in the comments where. And subscribe now if you want real-time coverage the moment volcanic activity like this develops anywhere in the world. Let's get into it. At approximately 8:30 in the morning, local time on Monday, August 3rd, 2026, Guatemala's National Institute of Seismology, Volcanology, Meteorology, and Hydrology, known by its Spanish acronym INCIVMA, detected Volcán de Fuego entering a new and rapidly escalating eruptive phase. Over the following 7 hours, the volcano's monitoring parameters climbed steadily higher while it continuously emitted intense gas, ash, and incandescent lava fragments directly from its crater. By 4 o'clock that afternoon, seismologists had already recorded 9 separate higher amplitude seismic events and pyroclastic density currents. Fast-moving avalanches of superheated gas, ash, and volcanic rock began pulsing down the volcano's western flank into a channel called the Seca Ravine, traveling between 5 and 7 kilometers, roughly 3 to 4 miles from the crater. The ash and gas column itself climbed to somewhere between 5,000 and 6,000 meters above sea level, comparable in height to some of the tallest mountains on Earth, all of it generated by a single eruption happening in real time. What happened to that ash cloud over the following hours is what actually produced the darkness this story is named for. INCIVMA's tracking showed the plume initially spreading more than 40 kilometers, about 25 miles to the west of the volcano. As the eruption continued through the afternoon, that dispersal zone kept expanding, reaching 80 kilometers, roughly 50 miles, and extending all the way to the departmental boundary between Suchitepeques and Retalhuleu on Guatemala's Pacific side. Communities in San Pedro Yapocapa, much closer to the volcano itself, began reporting continuous ashfall coating rooftops, streets, and vehicles. By 9:15 that same night, just under 13 hours after the eruption began, INCIVMA's tracking data showed the ash cloud had extended as far as 130 kilometers, more than 80 miles, to the southwest. Aviation authorities were formally warned to exercise caution across a corridor stretching 60 to 100 kilometers west of the volcano, at altitudes between roughly 14,600 and 19,700 feet, precisely the altitude band commercial aircraft routinely fly through. For the people living directly beneath that plume, day did not simply get cloudy. It went dark in the middle of the afternoon, the sun blotted out by a column of ash thick enough to ground aviation across an entire region of the country. The eruption did not slow down overnight. Footage from a monitoring camera captured a powerful new explosion at 12:43 in the morning on Tuesday, August 4th, sending lava and glowing volcanic material further down the mountainside, while gas and ash continued billowing above the crater. By Tuesday, INCIVMA confirmed the volcano had moved into what officials described as a full paroxysmal phase, its most explosive and dangerous classification, with pyroclastic flows now racing down 6 separate ravines simultaneously, rather than the 1 or 2 channels active the day before. These pyroclastic flows are, without exaggeration, among the deadliest phenomena any volcano can produce. They are essentially avalanches of superheated gas and rock that can travel at speeds rivaling a passenger jet, with internal temperatures capable of exceeding 1,800 degrees Fahrenheit, hot enough to instantly ignite anything combustible in their path and leave almost no chance of survival for anyone caught directly inside one. Guatemala's Disaster Coordination Agency, known as CONRED, responded by declaring a nationwide orange alert, the second highest level on the country's 4-tier emergency scale, and separately raised the warning to red, the maximum level, specifically for 3 municipalities sitting closest to the volcano's most active flanks. The human response moved almost as fast as the volcano itself. Officials began evacuating the villages of El Porvenir and Las Lajitas first, the 2 communities directly in the path of the most immediate danger. As the eruption intensified through Monday and into Tuesday, that evacuation effort expanded to 8 villages total, with disaster management officials confirming that roughly 650 people had been moved out of the danger zone and into nearby shelters. By Tuesday, as the paroxysmal phase brought pyroclastic flows down 6 ravines at once, that number had grown to approximately 1,000 people evacuated. And by Wednesday, August 5th, with volcanic mud flows known as lahars still actively descending the mountain and incoming rain threatening to trigger even more of them, roughly 1,700 people remained in emergency shelters, with officials publicly stating that the next 72 hours would be critical to whether the situation continued to stabilize or escalated further. A major highway running close to the volcano, National Route 14, was closed entirely, and Guatemala's Ministry of Education suspended classes across schools in the surrounding towns. Here is the detail that gives this entire story its real emotional weight, and it is not something invented for dramatic effect. It is the specific reason Guatemalan officials are responding with this level of urgency and speed. National Route 14, the highway that was shut down this week, runs directly across a channel called the Las Lajas Ravine. That name should mean something to anyone who has followed Fuego's history, because Las Lajas is the exact ravine that, 8 years earlier, carried a wall of pyroclastic material directly into the communities of San Miguel Los Lotes and El Rodeo, along with the La Reunion Golf Resort in the department of Zacatepeques. That earlier disaster, the catastrophic June 3, 2018, eruption of this same volcano, remains one of the deadliest volcanic events anywhere in the world so far this century. According to official figures, 194 people were confirmed dead, with another 234 listed as missing and presumed dead, meaning entire families, and in some cases entire neighborhoods, were erased in a matter of minutes, as scalding pyroclastic flows buried homes so completely that some victims were never recovered at all. An independent investigation conducted after that disaster identified a specific documented failure at the heart of why the death toll grew so catastrophic: a serious breakdown in communication between CONRED, the disaster response agency, and the volcanologists at INSAVU-ME-H, who were actively monitoring the eruption in real time as it happened. Warnings that should have triggered immediate mandatory evacuations were delayed, diluted, or simply did not reach the people living directly in the pyroclastic flow's path before it arrived. That history is precisely why the response to this week's eruption looks so different, and precisely why officials themselves have been explicit about the comparison. As of Tuesday evening, August 4th, with pyroclastic flows already having raced through 6 separate ravines, authorities confirmed there had been 0 casualties. Not 0 deaths reported so far, pending confirmation, but 0 confirmed deaths at all, a genuinely remarkable outcome, given the scale and violence of what had just occurred on the mountain. Guatemalan officials attributed that outcome directly and explicitly to faster, better coordinated evacuations, the kind of institutional lesson that can only be learned by living through the alternative once already. CONRED's executive secretary, Claudine Ogaldes, speaking as mud flows continued descending the volcano's slopes, advised residents specifically in the 3 red alert municipalities to cover their water storage containers, to prevent ash contamination, and to use face masks as protection against continued ashfall, even as she confirmed that, as of that update, no mud flows had yet reached any village and no structures had been damaged. That is the sound of a disaster response system that learned, in the most painful way imaginable, exactly what happens when warnings arrive too late, and has spent the years since rebuilding itself specifically so that this eruption would not become a repeat of 2018. By Wednesday, CNN reported that the eruption, while still considered dangerous, was showing what Guatemalan officials described as a progressive reduction in intensity. But that easing came with an important caveat directly from CONRED, that accumulated volcanic material sitting near the summit was continuing to collapse under its own weight, even as the main eruptive activity calmed down, and that this ongoing collapse could still generate additional pyroclastic flows without a new major eruptive pulse being required to trigger them. In other words, even a volcano that is technically calming down can still kill people through the simple physics of unstable material sliding off a steep mountainside, which is exactly why evacuation orders for the highest risk communities remained firmly in place, even as the more dramatic lava fountains and towering ash columns became less frequent. Adding to the danger, incoming rain in the days following the eruption raised the specific risk of new lahars, the technical term for volcanic mud flows that form when rainwater mixes with loose ash and volcanic debris sitting on the mountain slopes, creating a fast-moving slurry with the density and force of wet concrete that can travel for kilometers down established drainage channels, sweeping away anything in its path with little warning. It helps to understand exactly why Fuego behaves this way, and why it has earned its reputation as one of the most consistently dangerous volcanoes on the planet. Fuego stands 3,163 meters tall, just over 12,300 feet, situated roughly 25 miles southwest of Guatemala City, and even closer to the colonial city of Antigua, one of Central America's most visited tourist destinations. Guatemala sits directly along the Pacific Ring of Fire, the horseshoe-shaped arc of tectonic activity responsible for the overwhelming majority of the world's earthquakes and volcanic eruptions. And Fuego is formed by the ongoing subduction of the Cocos Oceanic Plate beneath the Caribbean Plate, a slow-motion collision that has fed this exact volcano's magma system for thousands of years. Unlike many of the world's volcanoes, which erupt rarely and unpredictably, Fuego is almost constantly active at some low level, producing small explosions, minor ash emissions, and modest lava flows on an almost daily basis. That near-constant low-level activity is actually part of what makes major eruptions like this one so dangerous, because a population living beside a volcano that puffs ash and rumbles nearly every day can understandably become desensitized to warnings, making the difference between routine activity and a genuinely life-threatening paroxysmal phase harder to communicate clearly and harder for residents to act on with appropriate urgency. The historical pattern backs this up clearly. In 2023, an eruption at Fuego displaced approximately 1,200 people from their homes. Less than a year before that, an eruption in June 2025 forced authorities to evacuate more than 500 residents as a precaution, with disaster officials at the time praising the community's willingness to leave despite the disruption to their daily lives and property. And running back through the decades before that, Fuego has produced dozens of significant eruptive episodes, most of them contained and survivable, and then, in 2018, one catastrophic episode that redefined how seriously this specific volcano needed to be taken. That inconsistency, mostly manageable, occasionally catastrophic, is exactly the pattern that makes ongoing, rigorous monitoring so essential. And it is exactly why INCIVUME's scientists were tracking 9 distinct higher amplitude seismic events within the first 8 hours of this latest eruption alone, and why the agency continued logging dozens of additional seismic events across Guatemala in the 24 hours that followed, 34 in total, by one official count, a level of instrumented vigilance that simply did not exist in the same coordinated form before 2018, forced the country to rebuild its entire volcanic monitoring and public communication framework from the ground up. It is worth pausing on the sheer physical scale of what a paroxysmal eruption like this actually involves, because the numbers can be difficult to picture from a headline alone. An ash column reaching 6,000 meters above sea level is taller than most of the peaks in the Rocky Mountains, produced not by geological uplift over millions of years, but by a single volcano venting material continuously over the course of a single afternoon. Pyroclastic density currents, the specific hazard racing down Fuego's ravines this week, are not simply hot smoke or drifting ash. They are dense, ground-hugging flows of volcanic gas, pulverized rock, and ash that behave almost like a fluid, hugging the terrain and following drainage channels down a mountainside, with a combination of speed and density that makes outrunning one by foot or even by vehicle essentially impossible once it has started moving. Volcanologists studying these flows elsewhere in the world have documented speeds exceeding 400 miles per hour in extreme cases, with internal temperatures capable of surpassing 1,800 degrees Fahrenheit, hot enough to carbonize organic material almost instantly on contact. When officials say a pyroclastic flow traveled 5 to 7 kilometers down a ravine in a matter of minutes, that is not a slow-moving hazard people can watch approach and calmly step aside from. It is closer to an avalanche of superheated debris that arrives with almost no usable warning once it leaves the crater, which is exactly why the entire strategy for surviving an eruption like this depends on evacuating people long before any flow actually begins, not on trying to outrun one after the fact. That is also why the specific geography of this eruption matters so much to how Guatemalan officials responded. Fuego's slopes are carved with a network of established ravines, each one acting as a natural channel that concentrates pyroclastic flows and lahars into a predictable, if extremely dangerous, path down the mountain. Volcanologists have mapped these ravines for decades, which is precisely why INCIVUME could specify in real time that flows were moving through the Seca ravine on Monday and expanding to 6 separate ravines by Tuesday, rather than issuing a vague warning covering the entire mountain. That level of specificity matters enormously for evacuation planning because it lets disaster officials target the communities sitting directly in an active ravines path rather than evacuating the entire region indiscriminately. A distinction that becomes critically important when you're trying to move people quickly without triggering the kind of chaos and confusion that can itself cost lives during a rapid evacuation. One that extends well beyond Guatemala's borders to anywhere in the world that lives in the shadow of an active volcano. The difference between the 2018 disaster and this week's eruption was not a difference in the volcano's underlying power. Fuego produced genuinely extreme pyroclastic activity both times, flows racing down multiple ravines simultaneously, ash columns reaching miles into the sky, lava fountaining from the crater in the middle of the night. The difference was entirely in how quickly that danger was communicated to the people standing in its path, and how quickly those people were physically moved out of harm's way once that communication happened. 0 confirmed deaths from an eruption violent enough to send pyroclastic flows through 6 separate ravines at once is not luck. It is the direct, measurable result of a communication and evacuation system that failed catastrophically. Once killed hundreds of people because of that failure and was rebuilt specifically so that failure could not happen the same way twice. That is a genuinely rare thing to be able to say about disaster response anywhere in the world. And it deserves to be said plainly rather than buried beneath the more dramatic footage of lava and ash that naturally dominates coverage of an event like this. There is also a practical dimension to this disaster that rarely makes it into international coverage, but matters enormously to the people actually living through it, the sheer disruption to ordinary life that an eruption of this scale creates even in communities that never faced direct physical danger. Ashfall as light as a dusting can still contaminate open water sources, damage vehicle engines and air filtration systems, collapse weaker roof structures under accumulated weight if it falls heavily enough, and create serious respiratory hazards for anyone without proper protection, which is exactly why Conrad's guidance to cover water storage and wear face masks applied to entire departments well outside the immediate evacuation zones, not just the 3 municipalities under red alert. Agricultural communities across the ashfall zone, many of them dependent on coffee cultivation in the fertile volcanic soil that made this region agriculturally valuable in the first place, now face the ironic burden of dealing with crop damage from the very geological process that made their land so fertile to begin with. Schools across multiple towns remained closed well beyond the immediate danger zone, not because those specific communities faced pyroclastic flow risk, but because ashfall alone made normal outdoor activity and even safe travel to and from school genuinely hazardous for children. This is also not an isolated incident in a vacuum, and an understanding that helps explain why Guatemalan authorities treat every Fuego eruption with this level of institutional seriousness, regardless of how it ultimately turns out. Fuego is one of the most consistently active volcanoes anywhere in the world, producing some level of eruptive activity, whether minor ash puffs, small lava flows, or genuinely dangerous paroxysmal episodes like this week's on a near-continuous basis. That means Guatemala's disaster response and volcanological monitoring agencies are never truly off duty when it comes to this specific mountain. Insivame maintains permanent seismic and thermal monitoring stations specifically dedicated to Fuego, feeding continuous data that let scientists distinguish between the volcano's normal background activity and the kind of escalating signal that preceded this week's major eruption. That infrastructure did not exist in anything like its current form before 2018. It was built, expanded, and refined specifically because of what happened that June, in direct response to the documented communication failures that turned a survivable eruption into one of the deadliest volcanic disasters anywhere in the world this century. Volcanic activity has eased from its most explosive paroxysmal peak, but Insivame and Conrad continue tracking ongoing summit collapse, potential new pyroclastic flows, and the elevated lahar risk that comes with any rain falling on a mountain now covered in loose, unstable volcanic material. Access to both Fuego and the neighboring Acatenango volcano, a popular hiking destination that offers close-up views of Fuego's eruptions, remains closed indefinitely, with officials maintaining a physical presence at the trailhead, specifically to stop tourists from attempting to climb toward an active eruption zone. Roughly 1,700 people remain displaced from their homes, sleeping in shelters while they wait for confirmation that it is safe to return, uncertain how much ash, mud, or worse might be waiting for them when they finally do. If you take one thing away from what actually happened in Guatemala this week, let it be this. A volcano capable of producing pyroclastic flows hot enough to instantly kill anyone in their path, moving fast enough to outrun a car, erupted in one of its most violent episodes in years, close enough to a major capital city that its ash cloud disrupted aviation across an entire region and turned the sky dark in broad daylight. And because of lessons paid for in the worst way possible 8 years ago, not one person has died. That is not a story about a volcano being merciful. Volcanoes do not show mercy. It is a story about what a country can build in terms of monitoring, communication, and evacuation infrastructure, once it has been forced to understand exactly what is at stake when that system fails. We will keep tracking Fuego's activity as it develops, along with every update from Insivame and Conrad in the days ahead. If this gave you a clearer picture of what's actually happening on the ground in Guatemala right now, subscribe so you don't miss the next update, and tell me in the comments if you've ever seen a volcanic eruption up close. Stay safe, stay curious, and I'll see you in the next one.